Okay, so this is basically HEC-HMS on top of AutoCAD. You don't need to have AutoCAD installed. You can run this with. It also has a GIS in it, so it has the Autodesk Map 3D GIS. It also has MicroStation's library, so you can read and write MicroStation drawing files. What platform are you guys typically on? Do you use AutoCAD or MicroStation or ArcGIS? What's your preferred platform?
I think I mostly, yeah. I'd like to switch more to GIS, but so if you could kind of talk about both. But
I'm sorry, what was the first, what do you use there?
we mostly I use AutoCAD a lot, but I want to switch to using more GIS. So if you could talk about both.
Okay, all right, gotcha. Okay, and so you can use this for different stormwater projects. You can do this for flood studies, bridge replacements, culvert replacements. You could use this for land development projects, stream restoration, detention ponds, all that kind of stuff. So I'll go and start out. We'll go and load up a GIS file since you said you want to use GIS. So this is the new interface to our software. This will be in the next version of GeoHEC-RAS. So we'll go to our map data menu. You can just say add layers. And I'm going to go and grab some GIS data. So I'm going to grab these buildings, for example, these contours and this drainage. So if I select those, and maybe I want to put in my roads as well. So I could say road edges and whatever else, right? So road center lines are in there. So let's see, I guess it deselected these other ones. So contours, drainage, buildings, there we go. And hit open on that. It'll create a layer group for us. Automatically loads the data in by points, polylines, and polygons. You can change the draw order by just dragging those up and down. Okay, we can add a base map to this as well. So we can click on add base map layer. We have 16 different online mapping layers here. I'm going to use the Google hybrid one. I tend to use that the most. And then I can check my project coordinate system too. So I can go over to my file menu and go to map coordinates. You can see the projection that's currently being used. So I don't particularly like that projection. So I'm going to go over to North America, drill down the United States, go down to, this is in Ohio, so select Ohio, and I want to drill down to state plane datum, and I want to choose NAD 83 North Zone US Survey Foot. So you see a little preview window of that. And the yellow line is representing, the yellow outline is representing the actual coordinate system's limits, but we extend those out slightly in case you're on the border. Click on apply to map view, and then it will reproject everything to that projection. So if you bring in data that's in a different projection, it doesn't care, it'll reproject on the fly. So unlike AutoCAD, you have to do that all, you have to be in the same projection. In a GIS, you don't need that. Okay, well in this case, we have a land development project coming online here up to the east, and that's going to be flowing downstream in here and then eventually hitting this roadway crossing. We're concerned about that. So what we want to do is figure out, are we dealing with 1 square mile, 5 square miles, 50 square miles, 500 square miles of drainage area? So what we can do is go over to our watershed menu, select delineate watershed. It's asking me to save my work first because it's going to create a bunch of files. So let's just hit OK. And we'll go and put this in our work folder here. I'll call it, let's say, Stormwater project. And then it's going to ask me for that downstream-most location. So I'll click on pick, and I'll zoom into where that culvert roadway crossing is. Just click on the upstream side of that. It reads my site location as best it can, and then click on compute. Now it goes very fast because it's running in the cloud. It's running off our servers, but it's kind of approximate. It's not that accurate. So I'm going to, at this point, click on close, and we're going to zoom out here. We can see the extent of that. And I'm going to actually reorder this by just clicking and drag, just click and drag that. You can reset the order of those. And that's our watershed area. Okay, now what I want to do next is I want to go and do a more detailed analysis of that. So I can go over to my map data menu, select get USGS DEM. It'll take me in there. into my national map here, I can turn on elevation data, and I can zoom on in, and I can say, okay, what do we have available for, let's say, 1 meter data. So we'll say show. It'll highlight the areas that are covered with 1 meter data. We can say, okay, what do we have for 3 meter data? So I'll click on that, and that shows us a little bit more area. And I can say, okay, how about 9 meter data? So it's 9 meter spacing. So the entire US is covered with 9 meters. So you can see it at various levels, where depending where your projects are, what you're dealing with. So you can see between 3 meter and 1 meter, we got pretty darn good coverage. Of course, you could fly a drone with that as well and bring that data in, or you could have it in a Civil 3D surface and use that if you prefer. So anyways, we're going to go and use, I've got data loaded for this, or data for this, so I'm going to go and add that. So I'm going to go into elevation DM, just open that up, hit OK, and you'll see that loaded up. So I can validate that by turning off my base map, and if I zoom out to the extent of that layer, we can see the limits of that DM. But we're really only concerned with this area, so we'll zoom over to where that is. So I'll just right click on our watershed, say zoom to layer extents, and we're back in there. So I want to have it do a more detailed analysis of that watershed. So go over to our watershed menu, and we're going to say delineate subbasins, and we're going to choose our elevation surface we just loaded up. We're going to define the extents that we want to analyze. We're not going to look at everything, we'll just look at the data that we have loaded. So let's click on pick, grab one of these, right click, say select similar, gets all the other ones, right click, say done. And we're going to use the terrain cell size. So just in this case, it's a 3 meter grid. So just hit next. And this runs on your graphics card, on your GPU. We found that that's much, much faster than your CPU for some operations. So those things that we can run on the graphics card, we do. And that actually runs 10 times faster than the CPU. And if you can run AutoCAD, you've got a graphics card capable that can run it. Anyways, the next part, it's going to take a look and say, there might be like a roadway embankment that's blocking the river, and it may not be able to figure out, where does that stream go. So this will automatically figure that out for you. Now, if you want to get more precise, you know exactly where a culvert crossing is or roadway crossing, you can draw in the bridge opening or the culvert barrel, and it'll burn that in that way. But I'm going to have it automatically do it. So just hit next. It'll take care of that situation. And then finally, we're going to define how big a subbasins how big a subbasin we want when we delineate this. So you can kind of play with it. So if I have 100 acres, I'm going to have lots of small subbasins. So I want to play with that number to make it seem reasonable. So I found that 500 acres seems to work pretty well. I'm going to go and then manually define our subbasin outlets. So just click on draw, and I'll turn off my base map, or turn off our, not our base map, our watershed boundary. Zoom on to the downstream end here, and I'm going to place a outlet right by that culvert. Now it can be off a couple hundred feet. It'll snap to that, but you want to be as close as you can. But anyways, now what we can do is look further upstream. We can see another roadway crossing there, so we'll zoom on in, place it right on the upstream side of that culvert. Go zoom out here, look at our next crossing. There's one right there, so we'll just put in our outlet structure, trying to figure out where that is. I think it's right there. And then we'll follow that up. And there's one last crossing there. So we'll just go and place it right there. Okay, so at this point you just say done and just hit next. It'll finalize that delineation. So you can do, like yesterday I did a site that had 174 square miles of drainage area. And we ended up with about over 60 subbasins, and that took about 45 minutes. So here it's only going to take a minute or two, if that. So in a matter of a few minutes, you've got your watersheds delineated, and they're fairly accurate. So next thing I want to do is turn off all that GIS stuff I had created earlier, and I'll go and turn off my base map here. And maybe what I'll do is I'll go ahead and turn off our GIS data as well. So turn that off. Okay, so at this point, this information is GIS. So I can go over to my Data Explorer, for example, select this subbasin, and you can see it's actually a polygon. And you can see the field information. There's a little link here. If you just click on that little link, it'll take you over to our knowledge base, and it'll tell you what all these attributes mean. So, I mean, some of them you can probably guess at, but all of those hydrologic properties, those parameters, you're limited to 10 characters when you define GIS fields for shapefiles. So anyways, that's why we've got some names that are kind of hard to understand. Okay, but anyways, this is all GIS data at this point. So we're going to go and convert this into HEC-HMS data. So go over to our input menu under drainage subbasins. We can draw in the subbasins, but I'm just going to assign them. Come in here, and I'm going to have it automatically name our subbasin. So I can give it a prefix. I can give it the number of digits I want. So maybe I want to have 2 sets of digits so that they're numbered from 01 to 99 or something. I can put in a suffix if I want. Maybe this is for existing or whatever. And it'll automatically name them. Then just go ahead and click on pick, grab one of them, right click, say select similar, right click, say done, and those are assigned. So now I can turn off my subbasin GIS data, and I see my HEC-HMS subbasins. Next thing I'm going to do is define my outlets. So go over to routing junctions. We'll say assign junctions. We'll go ahead and have it automatically name them. It'll automatically assign our invert elevation based on our terrain source. Click on pick, grab one of them, right click, say select similar, gets the other ones, right click, say done, and those are finished up. So I can turn off my GIS junctions. Next thing I want to do is define my streams. So go over to routing reaches. We'll say assign reaches. We'll have it automatically name them. Well, it'll automatically assign our reach slope, our downstream invert elevation, our flow direction based on our terrain surface. Click on the pick button, grab one of them, right click, say select similar, gets the other ones, right click, say done, and those are finished up. So we can turn off that layer as well. Okay, so basically at this point we've got our HEC-HMS model pretty much set up except our connectivity. It doesn't know where the subbasins drain to yet. So you actually have to connect those up. So you could either select one, select an element, just right click, say connect downstream to. But a simpler way, just go to your drainage submenu, say connect downstream, go and select all our subbasins. It'll look at our terrain surface to try to figure out where it drains to. Click on compute. And again, this all runs on your graphics card, so it's pretty quick. So now you can see these connections there. That's all set up. So next thing we're going to do is figure out our hydrologic properties. So we have built in the software all of this data available. So if you want to go and bring in percent impervious for the whole US, we have that mapped in. You can see that mapping in there. I can turn on a base map so you can see it better. So this ranges between 0 and 100. These are 75-foot pixels. Each pixel, it depends on what latitude you're at, but approximately 75 foot by 75 foot. So we have that data. We also have land cover data for the whole US. And that on top of just not only having the land cover, we have hydrologic soil group A, B, C, and D curve numbers associated with those. So if you're working with, let's say, open space and you've got a sea soil, it knows what the curve number is. So we're working with that data. Again, that's 75-foot pixels. Then we also have soil maps for the whole US. And we have all the different hydrologic soil group data is mapped in there. And all of these services I'm showing you are stored on government servers, but the government servers we found aren't that reliable. They go down, during the day, or sometimes they go down on weekends, or evenings they go down a lot of times. They're servicing the server or something. So we've made backups of all those on our own set of servers that run off of Microsoft server platform called Azure. And so if the government site goes down, it fails over to ours. So if you're working on a weekend or whatever, you need to get to this, and the government server's down, you don't even know it. It just fails over to ours. So anyways, we're going to use that data and figure out our hydrologic properties. So we're going to go over to our watershed menu. We're going to start here at compute slopes and just work our way to the right. So select compute slopes, select all our subbasins. It's going to use our elevation grid. Click on compute. And basically for each cell in that DEM, it's figuring out what the slope is for that cell. Then it's going to add that up for all the cells within the subbasin and come up with the average for each subbasin. Now this runs on your graphics card because it can run so much faster there. And so here you can see your computed slopes are, they're out to quite a few significant digits, but we store it as foot per foot or meter per meter, depending what units you're working in. But in HEC-HMS, some of the data they want it in foot per mile. Sometimes they want it in percent slope. The software will convert it on the fly as it needs it. Okay, next thing we want to do is figure out our percent impervious. Now, we don't actually have to download the data. The command itself will download it for us. So I showed you this data is available, but you don't have to select it. It'll figure out what you need and pull it down. So in this case, I'll turn on our subbasins, turn on our National Land Cover Database, click on Compute, and it's going to go and yank that data down because it doesn't trust I actually downloaded it, right? So it's going to validate that, download that, and then figure out our percent impervious for each of those subbasins by looking at each cell and assigning to each cell of that DEM what the percent impervious is, adding that up, coming up with the average. Again, that just runs on your graphics card and goes very fast. Now here you see it ranges from about 20.38 to 2407. Now I may not want to have two significant digits, decimal digit precision. So that could be, the DNR might say, hey, you're getting kind of crazy there. So go over to your File menu, go to Options, and you have a variety of different options here. You can set decimal digit precision for any variable, and for some variables, you can have it automatically round up to be more conservative. So like in percent impervious, you may round up to 1 decimal digit or round up to a whole number, integer number. Same thing for time of concentration, same thing for curve number. So if we go back over here to our map data and we go ahead and go back into our percent impervious, you can see now it's been rounded up to the next integer. So we're done there. Let's go and turn that layer off. Let's go ahead and look at our curve number. It'll compute that automatically. So we'll go turn on our subbasins, turn on our land cover, go over to our soil data, just choose that as well, and click on Compute. Again, it's going to go and grab that data. It's going to automatically pull that down. And this morning, the soil map server was offline. But today, this afternoon, I see it's up. So again, these servers come up and down all the time. But in our case, it fails over pretty much seamlessly. So it's downloaded that data. And then for each of these subbasins, it's figured out the composite polygons for each of these based on the soil types and the land uses. And then it's calculating your composite curve number. So here you see it's ranging from 62.5 on up to 84. And you can see the soil maps that were pulled down. And you could put these soil maps into your engineering project if you wanted to. Anyways, we'll go and turn off that soil layer, turn off our land cover, and that data is assigned. So now if we go look at our subbasin, if we just go look at, for example, infiltration data, you see your curve number, you see your percent impervious. Now you still have to come up with initial abstraction. There's a pretty simple equation for doing that, but just click on the Calc All button and it'll do it for all your subbasins. Now, HEC-HMS is kind of like the Swiss Army knife for stormwater software. So you have a variety of different infiltration methods. You have a variety of different runoff methods, a variety of different base flow methods, surface storage, canopy methods, all those are in here. So, but we'll just stick with the simple ones today. We'll look at SES curve number. You can set any of these to be your default. So if you have a county or a region that has a specific method they want you to use, you can set it as your default. So, but if we go over to our in runoff data, we can see we don't have our time of concentration or lag time calculated yet. So let's do that next. So we'll go and turn off our base map so we can see things better. I'm going to go over to subbasin flow paths. And you can see it's highlighting the DM that was clipped earlier. We're going to click on the draw button. And we're going to put, let's say, a raindrop right there. Put a raindrop over here. Click on a little raindrop, let's say right there. Right click, say done. Hit OK. And it computes our flow paths for that based on our terrain surface. Now, I might have hit it, might have got the longest one, but I'm not quite certain. Instead, we can have the software do that automatically by just going to longest flow path, and we'll just have the software do all the subbasins. So that's selected. We'll define these time concentration flow paths. I'm going to go and make this, let's say, 100 feet long for a sheet flow. You're not supposed to go over 100 feet, but I'm going to put 100 feet in there so we can see it better. And our channel flow segment, I'll make it like, say, 500 feet so we can see that. Click on Compute. And what it's doing now, what I did manually, it's doing automatically. Every 10 meters, every 30 feet, it's putting a water drop down and tracing out where it's going to go. So again, it's running on your graphics card. We can spin that up pretty fast because your graphics card actually has multiple processors on it. it's been optimized to play video games, right? So we're using the same architecture here to calculate all this stuff. And so it's ending up with hundreds and hundreds of different flow paths and then figure out which one's the longest. And then when it's done, it's going to extract a profile view of that. So here you can see this yellow line is representing what it had just developed, right? In fact, if I zoom on into the upstream part of this, we can see this red portion. That's our sheet flow. Then it's transitioned over to shallow concentrated flow. We can see that shallow concentrated flow travels quite a ways downstream till all the way down to the bottom here where we have 500 feet of channel flow. All right, so but anyways, we can see it should have treated channel flow all the way here till the shallow concentrated flow joined it. So we're going to have to correct that. But first, let's go and turn off the layers I created. Now, if you prefer to use one of the ones I created or you created, you can do that. But we're going to use the one I calculated. So we'll go and select it. You'll see it kind of glows on your screen. Double click on it. It brings up a profile of your time concentration flow path. So anyways, you can see the total length here is about 15,000 feet. And it automatically retrieves your rainfall data. So it looks up your 2-year, 24-hour storm and grabs that off of NOAA's Atlas 14 website. Fills that in automatically for you. Okay, so and it computes your slope. And you can just grab this interface if you want, move it around, and it will recalculate the flow lengths and your slope. But I want to place it where it exits or where the shallow concentrated flow actually entered the stream. So we click on Edit TOC Segment, and you can see the little green dot here representing the interface between the channel flow and the shallow concentrated flow. So just drag this over to where it enters, and right-click and say Done, and you can see that point is selected. So next thing, we'll grab the next subbasin. We'll come in here, pick this subbasin, click on Edit TOC Segment, just drag that interface over to where it splits out. So it splits apart there, say Done. You see that point. Let's grab the next subbasin. Come in here, got that one. Click on Edit TOC Segment, just drag this dot over to where it enters. If I right click, say Done, you can see it's actually the side of a highway. There's a roadway embankment there. Okay, now let's say we actually have a change in slope. So we want to incorporate that change in slope in our calculations. So at this point, just right click, say Add Segment, and come in here, just drag where that should be. And let's say this is some hillside, forested hillside. So we'll come in here, say, we'll select forest with underbrush. Now let's say this is some farm fields, it's agricultural. So we'll come in here, select agricultural. Let's grab the last one. We'll come in here and say pick, get this one here. And I'm going to say Edit TOC Segment. So sometimes it's helpful to have the aerial image on there. So we can turn that on and zoom on in. And we can see more precisely where that channel flow ends, right? So I can say, well, that channel flow ends right there, where that highway crossing, right there. So right click, say Done, and you can see that mapped in there. So next thing we're going to do is go and calculate our time of concentration. So click on Compute All. It goes through all your subbasins, all your different segments, and calculates your time concentration for each segment, then totals it together, gets the total time concentration, and then there's an equation to calculate the equivalent lag time. So go and close that up. And now if we go and look at our original subbasin that we were looked at earlier, if we double click on it, we can see our time concentration or lag time there. And again, you can change the level of digital precision there, as I showed you earlier. So our subbasins are defined. Now we might want to go look at our routing reaches. So let's go ahead and I'll turn off the base map so we can see things better. I'm going to turn off this flow path line as well. So go to our HEC-HMS properties dialog. And in here, I'll just toggle off flow path. All right, so next thing we're going to do is go and cut a cross section through here. So we can go over to our input menu, go to cross sections, just say draw cross section. We'll have it automatically name them. The cross sections will be named the same name as the reach. So if let's say you're working with several river reaches, you might have reach 109. So your cross section will be 109. So you can only have one cross section per reach. So then we'll have it read our elevation data, and we'll extract our data. We're going to limit the amount of data it extracts. I'll say 20 feet deep, and I'll say go out to 1,000 feet to make that happen. We'll come in here, also assign some bank stations. We'll do it based on some channel depth. And then we can go and map in our roughness values as well. Go and click on draw, and just draw in where your cross section should be. So again, you might want to put that aerial image in there so you can see where to draw it, but I'll just say it's right there. You can draw this left to right or right to left, it doesn't care. It'll figure that out. So if we go and zoom in on that, we can see our roughness values mapped in there. If we double click on the cross section, we can see the actual geometry it extracted, and then we can see the equivalent 8-point cross section, and it also develops a tabular cross section. Now the tabular cross section and the 8-point cross section is supposed to be an approximation of the real geometry. Unlike HEC-RAS, which uses real geometry, you have to develop an equivalent one. Well, the software does that for you. So it's looking at here at different heights, and here we're jumping up a half a foot, and it's measuring our top width, calculating our flow area, and calculating our discharge rating curve automatically. So it does all that work. You have to do this manually in HEC-HMS, but here it's done automatically for you. Okay, so that's done. Now if you have to do a whole bunch of those, that gets pretty old pretty fast. So one way to do it is you can go to global editing and say, I want to find all those reaches that don't have this data defined, and then I want to go and globally edit them at the same time. But you end up working with like SQL statements, and it's not that bad, but it could be easier. So the guy said, hey, let's just do it. Let's make it really simple. Let's just go and define it at one spot. I'll just double click here, for example, and let's go over to our routing data. Let's say we're going to use a trapezoid shape here. I'll put in, let's say, a bottom width of 10 foot. Let's say it's got a channel side slope of 1 to 4. So for 4 foot a run, it's got 1 foot rise. You also have to give it kind of a starting discharge, or not a starting discharge, a maximum discharge, so it can kind of come up with like a rating curve table for initial conditions. And then click on close. So I've defined it at one location. So what I can do here is I can right click on this, say copy properties, and then I'm going to go over to my selection set menu, say invert selection, and it flips it for me. Then I can just right click anywhere and say paste properties, and it says properties have been pasted. So now if I go examine one of these, for example this one, you can see that same data is defined. So there's lots of little workflow automation tools built in here. So our model's set up. Next thing we want to do is define our storm. So go to meteorology data, and lots of different storm types. So if you're doing like a probable maximum precipitation storm where you have to use HMR 52 and 51, that's built in the software. So if I go over here to precipitation data, I can say, let's just say it's our storm centered on our subbasins, and we can go in here and we can say retrieve HMR 51 PMP data. It puts you in a plot showing you the isoheats. So these are contours of rainfall, total rainfall, and it automatically interpolates what it is at your site. So it's based on storm area and storm duration. So you have to do this manually, the old-fashioned way, looking on a piece of paper. Here you just click on a button and it fills in your table. So you're done. So you can also go in and put in a rain gauges, multiple gauges. It'll calculate your theta and polygon network and weight the rainfall to each of your subbasins. You can go and put in actual rainfall distribution. So if we look at Wisconsin, they have a specific one they want you to use now. So we go over to the United States, we can go drill down to Wisconsin. And then we have MSE, that's Milwaukee Sewer District. So we have their rainfall distributions. Oh, that's MSE, sorry, here's Southeast. Southeast, we got the sewer district down there. We've got their rainfall data. And we got the MSE. So you got to choose MSE 3 or 4. So you can see that plotted in there. You can say cumulative plot. You see it better when you compare. All right, so you have to choose which one you're in. Or you can just use the standard SCS method. So if we go over here back into general specs, we'll switch it over to, let's say, SCS storm. Go over here to precipitation data. Notice now it's actually grabbed my location. By centering it, looked at the center of the subbasins. And then I choose my storm interval. And I'm looking at a 100-year storm, let's say 24-hour storm. Click on retrieve from NOAA, and it gets your rainfall data. Grabs it out. And then if you're in a coastal area, Wisconsin's not in a coastal area, but if it was, it figures out if you're type 2, type 3, type 1A, type 1, does it automatically. Then go and look at the actual rainfall. So it shows you where it got the data from. And of course, you might want to take that, put that in your engineering report, right? We want to make it bigger, the thicker report, right? You spent more time on it. There it is, here's your report. And you just PDF that, put that in your report. Okay, so at this point, we're ready to go run this thing. So we might want to rename this storm. Let's do that. We'll call it our 100-year 24-hour storm. So you might have several different storms, right? You could have the 2-year water quality storm, 10-year typical storm, whatever. You can have multiple storms. So in fact, let's rename our scenario, our plan. So we'll come in here, we'll call this, let's say, existing conditions. And I'm going to take that same text here and copy it over into all these things. So we got that set up. So let's go run it. Go over to analysis. Hit the little, we want to tell it how long we run the model. So we're going to come here, we'll say, we'll start our simulation today. It's the 18th, and I want to run it for 1 day. So I'll run it till the 19th. That's 1 day long. And I'll have a computational time step of 5 minutes, which is typical. Click on close, and just hit the little running person, and it runs HEC-HMS. Now we support all versions of HEC-HMS, so whichever one you want to run or you need to run, you can select it and run it. So we're done. Let's go and close this up. Let's take a look at our results. So we can select that outfall. Just right click, say plot hydrographs. We can see our hydrograph plotted. And we might want to compare that to another location here. So you say junction 3, for example. You can see the different discharge here. You can also measure the difference. You can use the little measuring tool. Come here, click on your peak. Come here, click on that peak. And you can see the difference time offset from the 2 peaks. And you can see the discharge change. Or if you want, you can just go to your data summary table, and it kind of summarizes it for you. So here you see your difference in your peak flows and your peak difference, or you see the difference in your volumes. Or you might want to go and select items off the map view. So just click on pick elements. Let's say you want to look at that subbasin, this subbasin right there. Right click, say done. And you can see those plotted. You may want to add that to your engineering report. So just right click and say copy and put it in your engineering report. But the reporting's done automatically. So I'm going to show you that in a little bit. So let's say this is our existing conditions. So we want to consider our proposed development now. So go back over to our input menu. Under scenario manager, we'll say duplicate current scenario. But let's call this our proposed development. Right? Maybe it's a we'll call it maybe a shopping center or something, right? Or a business center or something like that, right? Maybe a business center is a better name. All right, and then we'll go and copy the basin model. So we'll have 2 models now. Click on apply. We have our proposed development and our existing conditions. So let's say you're coming in there, doing some earthwork, and your watershed boundaries are going to change. So what we can do is go over to our map edit menu, select reshape polygon, come here, pick this polygon shape, and we can go and just redraw this. For example, click on draw, and I'm going to come in and just say, well, I'm going to take it up to this road and then follow along this road, and we'll go in and follow this. Now notice I'm in a curvilinear command right now. To toggle back and forth to a linear, just hold down your control key. And if you want to go ortho, hold down the shift key. So now it's in ortho mode. So this one command allows you to toggle back and forth in there much easier than what you can do in CAD. So we'll go in here, lay this in here. Of course, CAD has some other options too that are more meant for more precision, but this will work quite well for us. Right click, say done, hit OK, and it's done. Now you can also use this if you have 2 adjoining subbasins. So for example, let's say you didn't like this joint here, you could come in and clean that, say I want to follow along that road. So you can use the same command for that. Okay, so to toggle back and forth, just to show you here, we can go over to our existing conditions. There's not much difference here, but you can see at least see the toggling between there. Now if you need a manually drawn a subbasin, let's say for some reason you have to do that, go over your drainage subbasins, just say draw subbasin. I'll draw in a curvilinear line, just click on draw, and let's say you're going to just draw from, let's say, over here on over to there, say done, and notice it automatically follows along the common edge. So again, all that automation is built in there. So because we're written on top of AutoCAD, we can simply undo that, and we're right back where we were. Now we want to consider that new development that's coming in there. So what we're going to do is we're going to switch out our base map. Let's go switch over to the street map Google, and let's go ahead and go to classify land use. This will display another panel here, and we're going to go and create a land use layer. So I'm going to come here, say add new layer. We'll call it, let's say, land use proposed. Okay, and so it's going to create a new layer we're going to train the software on. So now you could go out and grab like a Mr. Sid file or whatever, use that if you want to train the software. I'm going to use the Street Map Google to do that, but I want to tell it the limits of my training. So I select user defined limits, click on pick, and I'm only really worried about this lower subbasin. So I'll just drag a box around that. It'll use that to kind of figure out, okay, that's the limits that we're going to use to classify this land use. We're going to choose what image zoom level we're working with. So click on pick and then zoom on in. Now if you have a Mr. SID file, Mr. SID file actually has multiple layers. As you zoom in more and more, you get more and more detail. Similar to like what you get here. As we zoom into our Google Street View, we start seeing buildings and things like that, property lines. We don't need that. So we're gonna back out so those disappear. And they're there, they're gone. So I'm gonna right click, say done. And that happens to be at a Google Street View level 9. So we're gonna use that. Click on OK, and you can see a new layer show up over here. So click on OK. Makes a copy of that layer. So now we actually have 2 layers. We have the online map, which you see there, which is right here, and you've got the copied map. So I'm going to turn off the online map so we can now see the copied image that we've created to kind of train the software. So let's go and turn off our HEC-HMS layer. And we want to classify this based on land type, based on what we're seeing on the map. So you could use an aerial image for this, but here we're going to use the Google Street View just to kind of simplify things down. So we give you some sample land uses to get you started so you don't have to start out dry. And you can always add more. Just hit the browse button and just kind of look through here. So maybe you have some industrial area, you can select that, hit OK. It'll add industrial, or if you don't see it in this list, just go and type it in and type in your curve number. But anyways, we have some forested area. So we're going to go over here to woods. We'll say pick sample. We'll just kind of paint in where our sample is. Now, if you're dealing with aerial imagery, you want to capture representative samples of what that wooded area looks like. So you might have clumps of different trees. So you might want to go in there and get lots of different samples. The more samples you give it that are different, the easier the software is able to learn from what you're telling it. So it has some sort of a machine learning component in it to try to understand what's there. So it's like teaching Google what a cat is, right? You show Google enough cats, it's going to be able to recognize the difference between a cat and a dog. Same thing here. If you give it enough samples, it's going to figure out, okay, this is wooded trees and this is grass. So it's something similar to that. In this case, we only have one color, so it's relatively simple. So we'll just work with that sample. We'll come in next, go in here. We've got some open space here, so we'll select open space, kind of paint that in. We have some water in here too, so I'll select water, paint that in. And then of course we have some roadways here, so I'll come in and select roads. And if you make a mistake like that, not a big deal, right? You can simply undo that. So we're going to go and draw in where our road is. Now if you're drawing real roads, you're going to have real roads from an aerial image. You're going to want to get lots of samples because roads are all kind of different colors. And sometimes I find I just leave the roads out and I do it manually. Okay, but anyways, at this point I've kind of trained it, I've given it enough samples, it can probably figure it out. So just click on classify land use, and again this works on your graphics card, so it goes relatively fast because we're able to leverage the processors on your graphics card, and there it's done. So if we want to go look at this is actually GIS data at this point. So if we select this, you can see all the different attributes that have been mapped in there. You can see the land use type. Now you can switch it out. If you want to make it something else, you could. I could switch it over to water and the whole thing would become water. But I'm not going to do that. But you can see it kind of messed up. If we zoom on in, you can see where this label was. It says, I don't understand what this is. This is not something I'm used to seeing. So it clipped that out. So we can fix that. We'll go over to draw land use. We'll go to paint overwrite. We want to choose open space, and we can then change our paintbrush size. And it's kind of like PC Paint. You just go in there and paint over it. There we go. It's finished, right? And you can see, well, I missed a little spot right there. Okay. And you can see our roads aren't very well done because it's got this text in here. So let's select roads and change our paintbrush size, and you can go in there and paint that as well. But unfortunately, I'm in an overwrite mode, so I didn't want to really do that. So let's undo that by Control Z and just say paint clipped now. And now it will be clipped to whatever is available, right? So anywhere there's no land use defined, I can just paint it in, it'll take care of it. Okay. So let's go put in our business center, our land development. So we're going to go select commercial. We'll pan over here. It's right along this edge here. So we'll select commercial, change our paintbrush size, and we can use the other command. So if we already have it in CAD, we just click on the line and it'll trace along it. I don't in this case, so I'm going to just draw it in. So we'll kind of come in here, just follow along this property boundary right alongside that roadway. Lay this in here. Okay, now I'm still in a curvilinear mode, so I want to go to linear. So hold down the control key, take it down. Then I want to go south here, and I want to go in ortho, so I hold on shift key, take this over to, let's say, right there. Take this over. Now I want it to connect up to here. So what I can do is just put your cursor right here, click, and then click again. It closes on itself. Just right click, say done. Now we want to fill in between here. So choose your fill area command. Just click this, click that. You're done. Now you can see it messed up along this interface. So we can come in here, say paint overwrite, change our nib size, and just kind of paint in where it didn't fill in. It's done. So at this point, we've now classified that. We can utilize that for calculating our curve number. So go over to your Watershed menu, turn on your HEC-HMS layer, and you can see the land use covers that it created here. So we're going to map those over. So go over to compute curve number. We're going to pick our lower subbasin right here. And we're going to go to our land use data and turn off our national land cover database and select the polygon coverage we created over here. So we'll select that. We want to choose land use proposed. And notice it's auto-populating our fields. Click on compute and it's going to recalculate now for us that curve number. And you can see the curve number right now is 62.5. And it switches up to about 68.5. So it went up about almost 6 points on your curve number scale. Okay, so let's go and close that up. Now we want to go ahead, let's turn off that land use data that we had, and let's turn on our base map again. Switch that over to Hybrid Map Google. And we want to go and run these two models, right? So we can go over to our analysis, go to compute analysis, say multiple scenarios. We'll look at both. It'll run these simultaneously instead of sequentially. So it's going to run them on separate threads on your processor. So let's say you have let's say you have a 4-core machine, which is a typical computer you might have, that has 8 threads. So one thread is reserved for the operating system, one thread is reserved for the user interface or the current application. There might be another thread reserved for something else that's running in the background. So you end up with like 5 or 6 more threads sitting there, not doing anything. So we'll run these on separate threads because HEC-HMS is written in Java. We can do that. So click on compute, and it's going to run those things simultaneously. Unlike HEC-RAS, which runs one, then runs the next one, then runs the next one. These are run simultaneously. Now these models are so small, they run pretty quick. But if you have a big area like the one I had for 174 square miles, it might take 5 minutes. So if you have a bunch of different scenarios you want to run all at the same time, it still takes 5 minutes. It doesn't take 5 minutes plus another 5 minutes plus another 5 minutes until it's done. All right, right now we'll just right click on this, say plot hydrographs. And we can see our hydrograph there. Now we want to, this is our proposed development. So we're going to go over here, look at existing conditions. And we can see our existing, let me turn this plot off. So there's not a huge difference, but we can zoom on in. And of course you can measure that difference if you want, or we could go over to our data summary. And we can see in here the two numbers, and it's a difference about, it looks like about 70 or so. So somewhere around there, 60 to 70. So 70 CFS difference. And our volume went up about 14 or 15 acre feet, about 14 and a half acre feet. So we're going to have to put in a pond for that. But now we want to create a report, let's say, for example. And when I was a practicing engineer, I hated writing reports. It took that burned up the whole, you get the engineering part done pretty quickly. Then the reporting took forever, right? Did you put this paragraph in? Did you go home at night, you're sitting in bed. Oh, geez, I forgot this part. So we said, let's put it in so we don't have to deal with it ever again. So we'll go to results, go to generate report. Let's go grab your company logo. So I grabbed that yesterday. Let me see if I can find it here. HIJK, where is it? KKK, there it is, right there. And put in your project title. So let's call it Proposed Business Center. And project subtitle, let's call it like Stormwater water hydrology analysis report. And prepared for, I'm just gonna make up a company here. Let's say ABC and Development Corporation, right? And then prepared by. Now I copied your company address just before our meeting here, so let me grab that. I didn't know which office to get, so I just grabbed your one in Rothschild. And let's say I want to put a blank space there. Let's say we're going to submit this report. You said we got to submit it by Monday, so I'll put Monday's date on it. And so you can set this up as a template. So you might have a separate Word document. This is saved as a Word document. And you could put your own boilerplate text in there. So you might have hard-coded text you always put in all reports. Some sort of preamble or something that's in that report. So you can modify these templates. You can have a template for land development, one for stream restoration, one for flood studies, one for dam failure modeling, and so on. So you just select the template you want. And we can go to general settings. We can set up, how we want our page numbers to be. Do we want a watermark on there? Maybe we want to mark it preliminary, right? So it'll be a watermark in there. What kind of date format? Do we want headers and footers? You could put the headers and footers in the template document if you want, or you can put them here. Go to your project map. Go to your region map. Let's zoom in on our region so we can see it better. Get that located. And go to our map preview. It kind of puts those guys together. So I can see this project map is overlapped. So I'm going to come in here. I'll just pan this over a little bit and go to map preview. It's still covered up. So let's zoom out just a little bit. Park it over here. Go back in. That's looking better. Okay, so at this point I want to maybe add a scale bar or like a north arrow. So click on edit. It'll take you into like a little diagram editor. This is kind of like a simplified version of AutoCAD. So we can go over here, say, put in like a north arrow. And so we got all the different north arrows that we were able to find on the internet. We basically replicated them. We'll grab that one there, for example, just pasted it over here. And maybe you don't like the colors, right? So you can come in and just change the color this fast, right? I changed the arrowhead, change the text size. Maybe true north is off a little bit. So we can come in there, rotate that a bit. Let's put a scale bar in. So you can choose what scale bar you prefer. So I'll go and put this one in. Just click where you want to place it. And this is dynamic, right? If I grab that and I resize it, you see it dynamically resizes. Okay, let's put our development site, business center in there. So we'll go over and say draw shape. Let's say put a little rectangle in here. Just draw in where our business center is going to be located. And maybe we want to change its color, right? We'll come in here, make it white, make it line weight a little bit thicker. Maybe it's rotate a little bit, right? And let's say we'll put a little call out for it. So we can come in here, say draw call out. Let's draw it with a red line. So let's go and change our line color to red. And we'll draw it here down to here. Say done. And we'll call it business center. Type that in, business center. There we go. And we'll go and make that bigger. And you can make it bolded if you want. You can grab this this label and move it around. Get it precisely located where you want. And maybe make that line thicker. So you can tweak this as you go, right? And let's say we want to go and show where it is down here. So we'll go and say draw polyline. Draw another line down over to where that business center is. We'll just say done, and we'll put an arrowhead on it. Okay, and at this point, we're finished, right? We'll just say save edits. That's done. And then we'll go to our table contents, and you can change this, right? Instead of proposed development, we'll say proposed business center. Okay, so you can come in here, change any of the labels. You go your routing diagram. This creates your HEC-HMS routing diagram, which is HEC-HMS doesn't do a very good job. So you gotta kind of tweak things, drag things around, and get them located where you want them so it looks better. But you have total control here. If you want to like scale this up, you can scale it up. You want to put labels in there, you can do that. Go to your time series plot. You can create your own graphics. So we can come in here and say existing and proposed. We'll choose, let's say, that downstream junction. Click on the little browse button. We'll pick that guy right there. And that's junction 1, so we're good. Let's change the name of that plot. We'll call it, let's say, culvert discharge. And let's grab another one here. We'll say existing and proposed. Now we'll grab our subbasins, for example. Let's grab that subbasin that development's on, and we'll call it business center subbasin runoff comparison, right? Getting kind of wordy there. Okay, so you can keep adding more and more plots there, and you can specify how many plots you want on a page. Click on generate, and then if you've got Microsoft Word on your computer, it's going to automatically launch Microsoft Word and load up your report. Now, right now it's asking you to build a table of contents. Just say yes to it. Unfortunately, Word locks you out from doing that. So there's our company title, or I should say our logo. We've got our title, our subtitle, who was it prepared for, prepared by. It's got our submittal date. Then it's got our table of contents, which is hypertext linked, and it's also over here. And you can see your diagram we created, right? And it takes the address of the center of the subbasin. So you probably want to go and type. You probably want to go and edit that, right? So you're in Microsoft Word. You can just type something in. It tells you the site area, and then it shows you the purpose. Now this is boilerplate text. You would want to change this, right? Modify it for the specific project. What version of HEC-HMS was used, and then our two scenarios: existing and proposed business center. And then it shows us our schematic for existing conditions, and then our design storm, and then our summary of all the watersheds here, or subbasins. So we can come here and look at our subbasin, our drainage area, our initial abstraction, our curve number, our percent impervious, our lag time, and peak discharge. So it's all summarized. You don't have to go into Excel or something like that and do that manually. It's done for you. Okay, and then you can go down, and then it has a summary of each subbasin. So you can see this is subbasin number 1. Existing conditions, what was the computed peak discharge, was the corresponding drainage area, our initial abstraction, our curve number, our impervious surface, our lag time. Then HEC-HMS gives you a bunch of other stuff, gives you depths and volumes, and then we want to go in and it gives you your curve number. How did it calculate the curve number? Well, it gives you that. It gives you those calculations right there. Right? And if you want to copy that in Excel, you can just right-click copy it. Here's your time concentration calculation, your lag time. And then it shows you a plot of your precipitation and the corresponding runoff. And then on to the next subbasin. It keeps on going through here until the very end. You got your pre-post development at the bottom here. Those are your custom plots that we put in. Remember, business center, subbasin runoff comparison table in there. Okay, so now you might want to add some more to this. So what we could do is we could say, well, we should have gone out for a site visit. In fact, we did a site visit on this about a couple of years back. But just to show you here, things that you might find helpful is we can go in here and just put in a little Google Street Person. It'll drop us in there and place us into Google Street View. Right within your engineering project. So this culvert is right down here, right there. And I can say, okay, that's where it is. You can see I'm pointing right at it. And I could say, well, let's zoom out on a camera a little bit. And I want to add that to my engineering report. So click on the little camera button. And it takes a picture of it and adds it to your project. So you're adding pictures to your project right within the software. So there it is. You can click on that picture. You can see a picture of it. This picture was taken by Google in August of this year. It tells you what elevation the Google car was at. So it's at 748 foot elevation. And what's the street address for it, right? Or you might have gone out to the site yourself and took some pictures with your camera, with your iPhone or something. And we did this last 2 summers ago. There's our culvert. Just hit OK. And that culvert's in there. But notice the difference between these two. The one has got a black bullseye, one's got a green bullseye. The black one means it's not georeferenced, doesn't know where it is. So click on the little black bullseye and just drag it over to where that picture was taken and drop it in and put your camera location there. And right now it's pointing north, so we have to fix that. We'll go and unlock our photo layer, come in here and just say graphic edit, just grab this, rotate that towards where it should be, and you're done. All right, so now if I hover over it, I can see my pictures in my engineering project. And you might say, hey, I want to go and see what's actually happening down here. So notice as I'm navigating in my street view, it's automatically navigating in my map view. Or you could go to your map view, just come in here, just jump over where it might be of interest. And we might say, well, wait a minute, there's that utility pole right there. Let's see where that is here. So it allows you to, right within the interface, say, okay, is that utility pole where we thought it was? Right, so you can use this kind of for other things other than just stormwater work. You could just use this for site investigation stuff or to help your surveyors. Okay, anyways, we want to go and create some output from this. So what we can do here is we can go over to our input menu, and under export data, we'll export this out to HEC-HMS. We're going to export this out to AutoCAD, to GIS. I'm going to send it over to Google Earth. Just click on export. It creates a KMZ file for you. Looks to see if you can find Google Earth on your computer. If it's able to find it, it'll launch it and load it up. You can send someone this KMZ file, and they don't need to have the software, HEC-HMS or anything. They can just go load it in Google Earth. They can click on a subbasin, and they can see the runoff and rainfall and runoff there, and all the input and output data. Similarly, we can go and click on an outfall. We can see what our culvert discharge is. We can go click on a reach. We can see our water surface profile through there. So they can review the results right there. And they'll think you spent hours making this up, right? You don't have to tell me click on a button. Oh, of course, you might want to also create an engineering exhibit, right? So let me go ahead and let me bring up Civil 3. There's Civil 3. Let me launch that. And I'm going to create a Civil 3 drawing. So we're going to go over to export data. We'll say export to CAD. Tell where we're going to save it on our computer. Tell it the drawing format you want. You can do this for MicroStation as well. Choose your resolution of your base map. So I would choose high resolution, but it takes about 1.5 minutes because it creates a Mr. SID file. Anyways, hit export. It writes it out to your CAD drawing. We'll go over to Civil 3D, go to File, Open, and we'll grab that file. Give it a second while it's loading up. It's got to reinitialize Civil 3D. Almost finished there. Okay, it's done. So if we zoom on in, we can see our aerial image. It's not very good for a medium resolution, but let me turn that off. But we can see in here on our layer here, which is called flow path, the label. So here we see our label for sheet flow. We see our label over here for shallow concentrated flow. You see your label for your channel flow. So if someone wants to see the actual, how did you come up with these numbers, show me the lines, it's done. So creating that exhibit is finished. All right, and similarly, you want to put this together does the same thing in GIS, I should point out, and MicroStation. But anyways, we say export this out to HEC-HMS. We create a zip file so it bundles everything together for us. And we'll go and put this on our computer. Let's create a name of this file. We'll just call it, let's say, HEC-HMS data, and export that out. It's done. Let's just go into our project folder. So it's under my consulting folder, under Akron, and there's my zip file right there. I'm going to extract that into a folder called HEC-HMS Data Stormwater Project. There's your HEC-HMS data that they're used to seeing. So now if I want to go look at that, let me go start up HEC-HMS. Get that to come up on my computer. Go to File, Open. Grab our project. We'll zoom over to where that is. That's under my C drive. Under Work, Consulting Work, Akron Stormwater Project, HEC-HMS data, a lot of folders here. There's our Stormwater Project. And there's your HEC-HMS data they're used to seeing. All right, now let's say we want to put in a detention pond. Just give me a couple minutes for that. I'll show it to you quickly. We'll go and turn on our CAD layer again. Where is it? Right. Oh, I didn't load a CAD layer. Oh, I have a GIS data. Right. So let's turn on our GIS data. Okay. So let's say this line right here, this blue line. In fact, let me move that forward so I can see it better. Let's see, is that the highest one? Yeah. So that drainage layer, I want to use that. So I want to make sure I deselect these other ones so I don't actually select them. So I want to use that layer right there. Let me turn off my HEC layer from being selected. This line right there. Let's say that's our subbasin. Or not our subbasin, pardon me, our detention pond. So we'll go over to storage areas. We'll say assign storage area. It's already selected. Let's just call it a pond. Okay, so let me make my stuff selectable again. So that's okay. So now we want to extract the storage volume for that. So right click on this, say extract storage area volume. We've got our terrain surface here. It's got an elevation difference about 6.5 feet. So we'll make this a 1/4 foot increment. Click on extract, and it extracts out our storage area volume curve. Then that's already been assigned. And let's say this now drains downstream, so we'll just right click on this, say connect downstream to. We'll have it discharge right to that outfall. And let's say you have this upper area. Let's say this upper area now drains this detention pond. Now you could have the software automatically redelineate this by just placing another junction here, just running that computation again. But I don't want to waste time here. So I'm just going to go and manually do it. So we'll go over to map edit. We'll say split polygons. We'll go in here, pick this polygon shape. And we're going to go and just draw in a cut line. Just hit draw. We'll start outside the polygon. We'll just kind of go along this pond, come back over to the stream, take it across over here, say done. Hit OK, and it's split. So now we have another subbasin. So we wanted to connect that up to that pond. So we right click on this, say connect downstream to, select that pond. We want to go look at our subbasin data. Notice we don't have a lag time, so I have to calculate that. So I'll just put in 60 minutes. Just give it something. Infiltration, we got to give it a curve number. I'll say 70. Calc out our initial abstraction. Also, our other subbasin, this lower one now, has gotten smaller. So I can go and maybe change my runoff. Let's say my time concentration is maybe 20 minutes now. And so now we want to define our outfall structure. So go to our pond, and we're gonna have the initial water surface match the invert. So I'll say match invert, and oh, it didn't grab that here. So let's see here. It should have gotten it. Let me see here. It didn't grab it. Let me just check it here. Let me right click and say extract storage area volume. Did I not hit OK? I didn't hit OK. So let's try this again. Say extract, hit OK. That time I think it got it. Let's try it now. Yep, now it's got that. So we'll say match invert. We got that. And let's go and define our outfall structures. We'll go over here to culverts. Let's say we're going to put in a circular culvert. And let's say you got 2 barrels. Let's say it's concrete pipe. And let's say our diameter is, I don't know, 3 foot. And our barrel length we can measure on our map view. I'll say 30 feet. Our upstream invert, I'll make it 812 to match our invert. And then the downstream side, I'll make it 811.5 so it has a good slope there. And then we'll have some culvert coefficients. We'll just leave the defaults. And then I'm going to come in here, define my spillway. Say we got a broad crested weir. And we'll put in a crest invert. I'll say maybe 816. And spillway width, I'll make it 20 feet. And a discharge coefficient, we can look that up quick. I'll make it 2.8. There we go. And then for, let's say we have a riser pipe. So we put an orifice, we'll put in 1 orifice, we'll say, let's say it's 814 for water quality, make it 1 square foot, okay? Now we want to run that pond, right? So we'll go back over to our analysis, and let's run it for more than 1 day. We're gonna run it because it's gonna take a couple days to drain out. So we'll make it 2 days, and I'll make it 2 days and 12 hours. So it's 2 days and a half, 5-minute time step. Go over here, hit your little running person. That runs your simulation now with your pond. And in our upcoming release, we'll have it so it automatically sizes the pond and assists you in designing the pond interactively. So rather than having to run HMS again and again and again, you'll be able to run the analysis right within one dialog and play with it and see dynamically how the water surface elevation is changing and how much discharge you're getting out of it. But anyways, at this point, we'll just right click, say plot hydrographs. You see your inflow, that was 703, and it's cut in half here, 332. And then you may want to see what is our, what's our pool elevation. So turn on pool elevation. And we can come in here and you can see it's still draining down. It's probably have to go a little bit longer. But we can come here and use our measuring tool, and we can measure just how much retention time we have. So come in there and you can see it's just shy of 1 day. So you can see how fast we can work with this. I don't know
That's
if
amazing.
Oh, super.
I mean, I'm really impressed.
Thank
I
you.
don't have any questions for you, but yeah, wow.
Super. Well, I appreciate you guys being able to attend this. I'm sorry about the GoToMeeting mess up earlier, but we got it up and working with Zoom. Okay. Well, thank you guys. If you have questions, give us a call. We got many support engineers here to help you out. I appreciate it.
Can't wait to use it.
Okay.
Sure.
Sounds good.
Thanks, Chris.
Thank you. Take care. Appreciate it. Bye, guys.